Thermal bending and gun tube droop. Stresses of both a physical and environmental nature like metal fatigue, design tolerances, and vehicle vibrations applied to various components of the fire control system. The FCS cannot compensate for most of these stresses, but it will compensate for muzzle displacement. Thermal bending and gun tube droop are two major factors that cause muzzle displacement. Thermal bending is caused by uneven heat distribution along the gun tube. For example, after being left out in the sun the whole day, the top part of the gun gets hot. When a muzzle reference system or MRS update was performed, the results showed the gun was way off down. In 1973, a thermal bend exercise was conducted at the Yuma Firing Center. Tanks without thermal covers were bore-sighted and fired at a target at 1,000 meters scale to represent a T-62 at 2,000 meters. Only half the rounds were on target. Tanks with various thermal covers were bore-sighted and fired at a target at 1,000 meters scale to represent a T-62 at 2,000 meters. Thermal bend exercise proved that the effects of thermal bending can be reduced by as much as 50% with the addition of thermal covers. Frequent bore sighting by crews with a muzzle bore sight device will reduce the effects of thermal bending. Gun tube droop. Gun tube droop is the gravitational pull of the gun tube downward. The gun tube is long and heavy and is only supported at one end, which causes the other end to droop and move the muzzle away from its original location. Fire control correction and muzzle displacement. Crews can reduce the effects of muzzle displacements, thermal bending, and gun tube droop by performing a muzzle reference system or MRS update until bore sighting can be accomplished using a muzzle bore sight device or MBD. Keys for fire control correction are good maintenance, MRS updates, and frequent bore sighting.